First of all, thank you very much for such attendance to our webinar. Really is the first webinar for me, and I had to be speaker near Peter and Remi and Horia to this web seminar. I want to introduce myself. First of all, I represent the Romanian Installation Engineer Association, like Vice President, and through Romanian Installation Engineer Association. We represent REHVA in the board and also in board I am responsible for the supporters committee meeting. I'm very interested about this issue because I manage 4 companies, and one of them it's involved directly in the air ducts venture production. And really, when Oli asked to me to attend the TightVent, I was very glad to do that. And for that, I want to thank you, Peter, to accept my participation. Okay, let's go to our topics. My presentation it's divided in 4 chapters. First of all, I want to introduce the European legislation and Romanian legislation. That some idea which we have in the Romanian legislation and Romanian regulation regarding building tightness and ventilation tightness. And after that, the step in which we are for the moment to attain the goal of nearly zero energy building in Romania. The main European legislation which we have, it's the Energy Performance of Building Directive from 2010 and recast APBD from 2002, the APBD from 2002, and the recast APBD from 2010. And of course, the SEN APBD standards. Regarding the Romanian legislation and regulation, in building tightness, we have the standards 6472 from 89, building physics, thermotechnics, calculus of air permeability of building material and components. Law number 10 from 1995, quality of construction. C107 from 1 to 7, requirement for new building, 1997. In 2005, Law 372, APBD transposition, and from 1st of January 2007, we have a new methodology regarding the new APBD methodology according with the SEN APBD standards, including the building envelope, include the certification, including the energy audit. And in 2010, the C107 was revised and it was proving the thermal resistance value. Regarding the tightness of ventilation systems, the methodology, the new methodology according with the SEN APBD, including the building services, the MISI A001 per 2 certification and energy audit. In the European standards, which become Romanian standard also, 2002-37 ventilation for building, ductwork strength and leakage of circular sheet metal ducts. From 2010, we have a new code in ventilation, code I5 normative document titled the Design, Manufacture and Operation of Ventilation and Climate Control Systems. The building tightness, it's mentioned in Article 4, the Law 372, the EPVD transposition, and in the methodology. And we find that here thermotechnical characteristic of the elements that make up building envelope, interior partition, and including airtightness. The envelope and airflow. The of air to the envelope can be source of heat loss. Because warm air can contain large amounts of water vapor, airflow is also the main means through which moisture passes through the building envelope. In winter conditions, air is forced to pass through the building envelope. Are coming out carriers had heat and humidity, and incoming air which is dry and uncomfortable create currents. Before passing through the building envelope, there must be an empty space. The pressure difference between inside and outside envelope. The pressure difference can be caused by a combination of wind, temperature difference leading the vertical thermal stratification phenomenon, known as chimney effects, and the equipment with burners and ventilation fans. Airflow between inside and outside provide many advantages such as save money and energy, building more comfortable without cold spots and drafts, protection of building material against damage caused by moisture, an increase of comfort, health and safety, remove clogged exhaust air and excess air and ensure necessary air to achieve safe combustion process, and a building cleaner and calmer. Controlling airflow involves three basic activities that must be made at once. Preventing uncontrolled leakage of air to the envelope, fresh air and exhaust polluted air, ensure the air circulation and necessary air for combustion in the house equipment. Building tightness. Tightness is important not only in the terms of capitalization energy and behaviors to ensure a good climate and building construction proper vapor barrier interior. The barrier prevents the penetration of moisture inside the building. Humidity encourages mold growth. It generates over time damage in the building on the one hand, and the production of allergy in the building to the occupants on the other hand. What is important is to do not forget that a completely tight building is unhealthy, even dangerous. Tightness ventilation systems, according with the normative document Code I-5, we have a table here with in the air tightness requirement for air pipes, which show us the maximum acid admissible for four classes of air tightness. The maximum air losses admissible for four classes of air tightness. We can see here the four classes mentioned by Remi before, which we have in our norms the times. Work related to the ventilation and climate control systems. We have procedure to evaluate the air pipe class and limit value for air losses in the pipes. And this table show how we can do that. Step will be taken to test the degree of airtightness of the air pipes. Air pipes belonging to class A do not require testing. A parts belonging to Class B shall be tested within the limit of 10% of the parts within a network, chosen and random. If these parts do not comply with the limit value given in slide 13, the test shall be repeated using another 10% of the parts within the network. Pipes belonging the Class C and D shall be 100% tested. Also, we should check the airtightness for ventilation system in the setting into operation, accepting and commissioning, and in the operation of ventilation and climate control system. Building with very low energy consumption versus net zero, nearly zero energy building. Passive buildings is the next stage in Romania in order to achieve the goal of nearly zero energy buildings. Buildings designed to ensure a high standard of energy efficiency and environmentally friendly buildings are called passive buildings. Designing passive buildings in general without traditional heating system and installation of air conditioning active, the result is the energy saving of 70–90% compared with the current housing found. The main element contributing to the low power consumption, taking into account the several demands of the health, comfort, and cost, are very high energy efficiency building envelope, high thermal resistance, void thermal bridge, tightness, control ventilation, and energy efficient. Example of definition and specification for passive buildings in the European country: German passive house, Energy, France, Minergie, Swiss, buildings with low energy class 1 in Denmark. A passive house is a building with thermal insulation quality which maintain a pleasant indoor climate using a main source of heating energy, passive free capture solar energy and heat from appliances. How now the feature of passive houses are the quality insulation, triple glazed windows, low E, without thermal bridges, control ventilation with efficient heat recovery, selling optimum building orientation for maximum solar energy capture and protection from prevailing winds, appliance with low power consumption, annual heat consumption up to 50 kWh per square meters, and total primary energy consumption is limited to 120 kWh per square meter per year. Before to finish and to thanks to all of you, I want to thank again for the possibility to come like REHVA partner of TightVent. And I want to invite you in 7th of October. REHVA organized a seminar, technical seminar regarding the recast of FPBD and other EU regulations. The venue will be the Hotel Boulevard, the Waterloo 38 in Brussels. 1 year ago it was Hilton. And we have a preliminary program and a tentative program which I show you for the moment. The next invitation is for next year. REHVA will organize the meeting in Timișoara, and the dates of annual meeting will be between 28 and 31 of March. And we will organize at that annual meeting with the topics refurbishment of European buildings for better energy efficiency. Thank you very much. And if you have questions, I'm ready.